One of the things we really like to do in mathematics is have the ability to shift points of view when looking at a certain problem or question, and linear algebra is no exception. For example, if you, let's say you know that a matrix is invertible, the question that may lead to is, well, what else does that tell you? What else can you say about the matrix? What does that really mean? Okay, and that's what we're going to look at in this section. So I'm going to start, though, by reminding you about the three types of elementary row operations. Remember, there's three types. First of all, you can interchange any two rows you like. Next thing you could do is you can multiply any of the rows by any non-zero real number. Or finally, you could add a multiple of any row to any other row. Right? We've been doing that for some time now. So here's an exercise. We're given the 4x4 identity matrix and we're asked to perform a row operation on it. Any row operation at all, any one of the elementary row operations. So here, you pick one and you perform it, and I'll pick one and I'll perform it in the meantime. We don't have to do the same one, but I'm going to take row 2 and interchange it with row 4. So what's that going to result in? Well, the first row won't change, but then the second and fourth rows will change. So here's going to be the new second row. It's the old fourth row. And then the new fourth row will be the old second row, and then the third row will be the same. So that's what you're going to get if you interchange the second and the fourth row. Okay, so what? Who cares? Well, whoops. Well, this is an example of one of the following. So we're about to introduce a new term. So we're going to introduce the idea of an elementary matrix. So an elementary matrix is just any matrix that you can obtain from the identity matrix, starting with the identity, but performing exactly one elementary row operation. Right? So the one we just wrote down, that's an example of an elementary row, or pardon me, an elementary matrix, because we got it from the identity using a single elementary row operation. Here's a few more examples. So here we've got a 3x3 matrix, and is it an elementary matrix? Well, ask yourself, if I were to start with the 3x3 identity matrix, could I perform one row operation, one elementary row operation, and end up with this matrix? So I'd have to start with the identity, though. So, well, the answer is yes. And if you think about it for a moment, you should come to the conclusion that if I perform the row operation, take row 1 and replace it with row 1 plus 7 row 3, and here's the part you really have to pay attention to. We're not doing this row operation to this matrix. That would be thinking about it backwards. What you want to think about is, imagine if you started with the identity matrix and then performed this operation, and you'll end up with this matrix. And that's the idea here. Okay, so because that's possible, because there is one row operation that you can do to the identity matrix to give you this matrix, then that means it's an elementary matrix. And of course, it's a 3x3 elementary matrix. But what is the point of specifying that? Well, what if I did this to the 4x4 identity matrix or the 5x5 identity matrix? This row operation would still make sense in those contexts, but it wouldn't give me this matrix, right? It would give me a slightly different matrix. So for every elementary row operation that you can perform, there's many different elementary matrices that correspond to it. If you want to narrow it down to a single elementary matrix that corresponds to the row operation, well, then you better specify the dimensions. Okay, so here's a 2x2 matrix, and you can see based on the way this is worded, it's already saying it is a 2x2 elementary matrix. What operation would it correspond to? Well, if you started with a 2x2 identity matrix, what would you have to do to it in order to obtain this matrix? And the answer is just interchange the two rows. Right? So if I interchange rows 1 and 2 of the identity matrix, then I'm going to end up with this matrix. Okay. Next example. Here's a 4x4 example. This is a 4x4 matrix, and it is an elementary matrix because I can obtain it from the identity by subtracting row 2 from row 1. So if I take row 1 and replace it with row 1 minus row 2, so I start with the 4x4 identity, perform this row operation. So I got it up here. Imagine I started with this matrix and then I did this row operation. Well, then that would bring me to this matrix. So because I can do that, This is said to be an elementary matrix.